Alright, for the final video, we're going to be looking at weight and temperature. Let's start with weight. And we'll start with the English system. Now notice the difference here. I'm going to write 16 ounces equals 1 pound. So OZ, remember that is ounce, and LB is pound. These are English measurements that you should be familiar with, I'm sure. Everything is measured in terms of pounds. And then we have 1 ton equals 2,000 pounds. So T stands for ton. For the metric system, here we have the common units for the metric system of weight. Probably the ones that they use most often are grams and kilograms. I know that they use milligrams because we use them for dosages, so I guess there's 3 really important ones. And then we have conversions between the English and metric. 2.2 pounds is approximately equal to 1 kilogram. 2,200 pounds is approximately equal to 1 ton. That's TONNE, which is defined to be 1,000 kilograms. So T, let me see if I got it somewhere. T equals TONNE. And then finally, probably the biggest connector of all is 1 ounce, well, equal to the pound one, is approximately 28.35 grams. Lasha, I'm going to try my best at this last name. It sounds like Talakhadze of Georgia, the country, not the state, lifted a total of 488 kilograms at the 2020 Tokyo Olympics. Convert that to pounds and tons. So as usual, we start out with the 488 kg, and then since I want it in pounds, I'm going to see if there's a connection between pounds and kg. I happen to know that there is. Let me put kg on the bottom because I need it to cancel, and then pounds on the top. I believe it was 2.2 pounds was 1 kilogram. So let me go ahead and put my 2.2 up there, 1 kilogram below, cancel, and let's go ahead and multiply. 488 times, oh, didn't quite get the second 8, times 2.2. And we have 1073.6. And these is in pounds. So that was one measurement. Now we also wanted it in tons. So I'm going to start with the 1073.6 pounds. And I happen to know that there's 2,000 pounds in 1 ton. So I can wipe out my pounds, and all I have to do then is take and divide. So I'm going to take, oh look at that, I'll just hit divide, 2,000. 0.5368 tons. Next, we're going to talk about weight and volume in the metric system. Now what they've done is everything is based on the weight of water. So these are all weights based on water. So let me do the connections here. We have the volume, the capacity, and the weight. Now the metric system has really been geared towards this. 1 cubic centimeter equals 1 milliliter, which equals 1 gram. So a volume of 1 cubic centimeter of water has a capacity of 1 milliliter, and it weighs 1 gram. Then we have this one, 1 dm, so this is decameter cubed. That's equal to 1 liter, and the weight of that is 1 kg. You can see that this system is very nicely done, very efficient. And then we have 1 cubic meter. That's equal to 1 kiloliter. Not something that I hear a lot of. But the weight of it is 1 ton. That's TONNE, which is 1,000 kilograms. So you can see their weight and volume connections are absolutely wonderful. Here's an example out of the textbook. It's a typical type of a problem that I thought is something you may encounter sometime in your life. You have an aquarium that you want to put on a table of some sort, and you want to know if the table is strong enough to hold it. And so you want to calculate the weight of it filled with water. So this is an example that does that. So let's go ahead and start. First, let's get the volume. Remember, this is going to be 91 centimeters times 66 centimeters times 46 centimeters. So we get 276,276 cubic centimeters. And now we're interested in connecting that to pounds if we can. So let's take a look at that. I'm going to start with 276 centimeters cubed. Now let's go ahead and take a look at my weight here. Right there we have a connection. The volume cubic centimeter is equal to 1 gram, so let's go ahead and do that. So I'll have 1 gram, and then I'll have 1 cubic centimeter. So I can wipe that out. Now I'm in grams. Now what I really need to do is get into kilograms so that I can then go to pounds. So I've got grams and kilograms. I know that. Let me go ahead and do that one while I'm here. I know that 1,000 grams equals 1 kilogram. So I can wipe out the grams. And then finally, to get it into pounds, I know that 1 kilogram equals approximately 2.2 pounds. So all that's left standing in the numerator is the 276,276 times 2.2, and all that's in the denominator is 1,000. So I'll multiply, let me move this to the side so I can see, by 2.2, and then I will divide by 1,000. So I get 607.8072. I'm just going to say 607 lb. if you use a different table or a different rounding, these answers can be different. I mean, quite different. Not substantially, but like it wouldn't, another attempt of mine came up with 609 pounds for the same thing, for example. Now, that's not the complete answer to this. We also want to add the 46 pounds, so the total weight we're going to have our 607 pounds plus the 46 pounds of the tank, and it looks like we're about 653 total pounds. You got to make sure that your table is capable of handling that kind of weight. Next, we come to temperature. And of course, we have a different system than the metric system. So we have the English and the metric. Let's take a look at water. This will be our base for everything. For water, we have boiling and freezing. These are two temperatures that we're well aware of. In the English system, we know that boiling water is 212 degrees Fahrenheit and freezing is 32 degrees Fahrenheit. Metric, boiling is 100 degrees Celsius and freezing is 0 degrees Celsius. So it's obvious they've given some thought to this as well. Now there's a connection between the two of them. It just so happens that the metric and English systems are linearly related. What that means is the formula that I have is this: F equals M times C plus B, where M is the slope, C is the temperature in Celsius, and B is the y-intercept. So let's take a look at the information that we have. On the one hand, we know that 212 degrees Fahrenheit equals 100 degrees Celsius. We also know that 32 degrees Fahrenheit equals 0 degrees Celsius. So I'm going to start with that one. So when I look at my formula, F equals MC plus B, I'm going to start with F equals 32, C equals 0. So I'll replace my F with 32 and the C with 0. Well, M times 0 is 0, so this means that B is equal to 32. So my formula that I have so far is this: F equals MC plus 32. Now I'm going to use the other piece of information. F equals 212 at the same time that C equals 100, and here's what I get. If I take my F equals MC plus 32, I can replace my F with 212. My M is what I'm actually trying to figure out. My C is 100, and there's 32. Now to figure out how to get M by itself, subtract 32 from both sides of this equation, and you get M times 100 equals 180. Divide both sides by 100. After simplifying, you end up with 9 over 5 equals M. This gives us our formula. F equals 9/5 C plus 32. As a quick example, let me bring this back. Convert 25 degrees Celsius to Fahrenheit. So this conversion is a little bit different from the rest of them. You're going to plug it into a formula. So my F equals 9/5 times C, which was 25, plus 32. Now, for simplifying purposes, you might want to think of the 25 as being over 1 because I'm going to cancel in this fashion. So I'll get 9 times 5 plus 32. That'll equal 45 plus 32. And so we get 77 degrees Fahrenheit. Now for the other conversion, here let me have F equals 9/5 C plus 32. What I'm going to do to solve for C is I'm going to subtract 32 from both sides first. And so I end up with F minus 32 equals 9/5 C. Now to solve an equation like this, multiply both sides by 5 over 9. Make sure you put parentheses around the left side. This way the 5s and the 9s all cancel, leaving C all by itself. So this, if I give you a Fahrenheit temperature, now you can give me the Celsius temperature. Convert 138 degrees Fahrenheit to Celsius. So C will equal 5/9. The F was equal to 138. Subtract the 32. 5 over 9 times 106. So we can just do 5 times 106 divided by 9. And we get 58.8 with a bar over it. That's degrees Celsius. Now what's interesting is if I told you the temperature today was going to be 58.8 degrees, you would think it's rather cool. Obviously, anyone who's used to metric system thinks that is rather hot. There is a cold temperature that we can both agree on is very cold. Convert negative 40 degrees Fahrenheit to Celsius. We know negative 40 to be extremely cold. Let's use the formula that we have. C is equal to 5/9. I'll write it again. F minus 32. That's 5/9. My F is negative 40 minus 32. That'll be 5/9 times negative 72. Well, it so happens that 9 goes into negative 72 negative 8 times. 5 times negative 8 is negative 40. So here, negative 40 degrees Fahrenheit equals negative 40 degrees Celsius. So it's a cold temperature we can both agree on is very cold.